Hey guys, welcome back to my channel. In the previous video, we did till sub question number 2 of question number 6, exercise 13a, chapter Indefinite Integral 1 from OP Malhotra's textbook of ISC Mathematics. Today we'll be continuing and we'll finish till sub question number 7 of main question number 6. So let's begin. Okay guys, so the third sub question is integral of 1 upon 1 minus sin x. Normally the way I would solve this question is I would multiply the numerator and denominator by the conjugate of the denominator. So this becomes 1 upon 1 minus sin x into 1 plus sin x by 1 plus sin x. Now we know that a minus b into a plus b is a square minus b square. So that's what the denominator becomes. It becomes 1 minus sine square x, which is ultimately cos square x. So that's exactly how I'm going to write it. 1 plus sine x by cos square x. Now we can do this as two separate terms. 1 upon cos square x becomes sec square x. And sine x by cos x we can simplify like this. Sine x by cos into cos. This becomes tan x. And 1 upon cos x becomes sec x. So sec square x plus sec x tan x. And we know that the integral for sec x is tan x, sec square x is tan x, and the integral for sec x tan x is sec x plus c, and this is the final answer. So let's move on. So the fourth sub question is integral of 1 minus cos 2x, 1 plus upon 1 plus cos 2x. Then we know that cos 2x is cos square x minus sine square x. So we can write cos 2x in terms of sine square x by converting cos square x as 1 minus sine square x, or we can write cos 2x in the form of in terms of cos square x by converting sine square x as 1 minus cos square x. So ultimately, okay, this would probably sound confusing, so let me just write it down. Cos 2x is cos square x minus sine square x. To write this in terms of cos square x, all I need to do is write sine square x as 1 minus cos square x. So this would ultimately become 2 cos square x minus 1, which is why we can write 1 plus cos 2x as 2 cos square x. Cos 2x can be written in terms of sine square x by converting cos square x as 1 minus sine square x. So I can write 1 minus sine square x minus sine square x. Ultimately, I can write 1 minus 2 sine square x, taking 2 sine square x to this side, which is equal to 1 minus cos 2x. So this is what we are going to replace, this thing. So ultimately, I can write 2 sine square x by 2 cos square x. The 2 and 2 gets cancelled, and this becomes tan square x. And we know that there is no specific integral for tan square x. So we can just write sec square x minus 1 dx. Integral for sec square x is tan x, and the 1 becomes x plus c. This is the final answer. So let's move on to sub question number 5, which is the integral of root 1 plus cos x. Now, because 1 plus cos 2x is 2 cos square x, 1 plus cos x is 2 cos square x by 2. This is half of this. So again, here we write the half of this angle. So we can write 2 cos square x by 2. The root 2 goes outside as a constant, and we are left with root of cos square x by 2, which is again cos x by 2. Now we know that the integral for cos x is sin x. So we write here into sin x by 2, because this is cos x by 2. And we also have to put in the denominator the coefficient of x, which is 1 by 2 over here. 1 by 2 into x is x by 2. So this becomes 1 by 2. Ultimately, we can just take this in the numerator as 2 root 2 sine x by 2 plus c. And this is the final answer. This is the final answer. Okay guys, so this next one is quite an important question because there is no specific like simplified term or for this 1 plus sine 2x. We know that 1 plus cos 2x is 2 cos square x, but there is no such thing for 1 plus sine 2x. So we simplify it in this manner. We know that sine 2x is 2 sine x cos x. So we can just write this. And we know that when we do a plus b the whole square, we write a square plus b square plus 2ab. And here this 1 can be written as sine square x plus cos square x. Let me just write this thing again. This integral, I am substituting 1 with sine square x plus cos square x plus 2 sine x cos x. I wrote it like this because ultimately you want to get rid of the root sign. So that's why I'm converting this entire term as a plus b the whole square. Sin x is a, cos x is b, this is 2ab, which is why I can write this as sin x plus cos x the whole square, because that will give me sin square x plus cos square x plus 2 sin x cos x, which will ultimately be simplified to 1 plus sin 2x. That's why I can remove the root by writing it in this form. It finally becomes sin x plus cos x. And we can see how simple this question actually is. The answer is so simple. Sin x is minus cos x, the integral, and cos x is sin x plus c. This is the final answer. And you would have thought that it would be very difficult, but look at the final answer. It's so simple. So just have to evolve your thinking. Okay guys, the last question for today is the integral of cos x root 1 plus cos 2x. Again, I'm going to write this in the form of 2 cos square x. I'm left with root 2 cos square x, because cos square x will come out as cos x when it comes out of the root sign. This I'll write dx here. So finally I can just take root 2 outside and write cos square x as 1 plus cos 2x by 2. Now I have root 2 outside and I have 2 in the denominator, which I can take outside. And then I have integral of 1 plus cos 2x. Now this becomes 1 by root 2 because it gets cancelled, and 1 plus cos 2x. Now we know that the integral of 1 is x. Integral of cos 2x is sin 2x by 2 plus c. Now to write this in more simplified terms, we can write it as 1 by root 2x, and sin 2x is 2 sin x cos x. So the 2 and 2 gets cancelled and we are left with sin x cos x plus c. And this is the final answer. So that's it for today guys. Thank you so much for watching. In the next video, we'll continue with the rest of the sub-questions of question number 6, and we'll probably start 7 and 8. So thank you guys. See you in the next video. Bye.